Mercury's shadow Frostbite. While you already know Mercury is one of the hottest planets in the solar system, it also has a bipolar personality, like Dr. Jekyll and Mr. Hyde. On its lighter side, it's hotter than a pizza oven. On its dark side, it's a lot colder than a walk-in freezer. That's why Mercury's shadow Frostbite is one of the more chilling ways to meet your end in our solar system. You'd think Mercury should be about constant roasting, but that's only half the truth. Mercury doesn't have much atmosphere to trap the sun's heat, so when the sun dips out of sight, the temperature drops to bone-chilling lows of about negative 330 degrees Fahrenheit in the shadowy spots. Now, Mercury is covered with craters, some permanently in shadow, particularly around the poles. These shadowed regions are like nature's deep freezers because they're so cold that they can even trap water ice, which is wild considering Mercury's overall hot reputation. But the catch for any unfortunate space explorer would be shadow frostbite, a danger that strikes without warning. Here's how it happens. If you were walking from the sunlit area into one of these shadowy craters, you'd be moving from searing heat into this extreme cold in seconds. It's the extreme version of suddenly moving from a desert to the North Pole. The sudden temperature drop could instantly freeze any exposed skin or surface, essentially freezing you in your tracks. Frostbite would set in faster than you can imagine because there's no gradual shift. It's like stepping straight from an oven into a cryogenic freezer. Your body wouldn't be able to regulate heat or handle the rapid freeze, and within minutes, hypothermia would start to set in, quickly leading to death. So the irony here is that you could die of cold on one of the hottest planets in our solar system. Mars dust storm smothering. Imagine you're exploring space, being one of the few people allowed to go to Mars, in the hopes of colonizing it or finding any proof life could exist there. The sky suddenly darkens, not because it's nighttime or an eclipse. Instead, you're in the middle of a Martian dust storm, a weather event that could make Hurricane Katrina look like a normal spring day. Mars dust storms can be enormous. A single Martian storm can wrap itself around the entire planet, turning Mars into a giant vacuum cleaner. And unlike the occasional sandstorm back home, Mars storms are windy enough to kick dust into the atmosphere for weeks or even months. The worst part is Martian dust is clingier than your ex. It's made of superfine electrically charged particles that stick to everything, from your helmet to your equipment and even your lungs. This dust is everywhere on Mars, and it's so fine that if you had a rip or tear in your suit, it could sneak right in. Inhaling Martian dust would be like breathing in a lungful of sandpaper, and your respiratory system would hate you for it. And as soon as this dust makes it to your equipment, your life support system will slowly grind to a halt because of the dust buildup. Before you know it, you're in a ticking time bomb of dusty doom. In other words, you'd be smothered, not just from the outside, but from within your suit's failing systems. It's basically the planet's way of telling you, welcome to Mars. Jovian lightning strike. Imagine Jupiter's atmosphere as a soup, but instead of normal ingredients like broth, salt, pepper, and a few vegetables, it's a turbulent combination of hydrogen, helium, and ammonia clouds, brewing some of the wildest storms in our solar system. On Earth, a lightning strike usually carries around 1 billion volts, which already sounds like Zeus is having a bad day. But on Jupiter, lightning can reach an unimaginable 10 times that strength. Picture a flash that's over 100 million times stronger than the power in your average household circuit. Getting zapped by this bolt would be like asking for the ultimate interplanetary shock therapy, but instead of a mild buzz, you'd be vaporized instantly. Jupiter's lightning storms are powered by the planet's sheer size and the intense heat from within its core. With a gravitational pull more than 300 times stronger than Earth's, it keeps a thick, massive atmosphere that creates wildly charged clouds. The atmospheric pressure then powers superheated ammonia clouds and violent updrafts, eventually leading to massive electrical discharges that make Earth's thunderstorms look like sparks from a birthday candle. Saturn's insane winds. The last thing you'd ever want to do when exploring the solar system is visit Saturn's atmosphere. This planet, with its lovely halo-like rings, is essentially the very definition of beautiful but absolutely deadly. Saturn's winds are among the fastest in the entire solar system. We're talking speeds that could make even the wildest tornadoes on Earth look like gentle breezes. These winds can whip around at speeds over 1,100 miles per mph, outspeeding any Formula 1 car on Earth by several times. Now imagine for a second you're in a super strong suit that can handle high speeds. You'd still face Saturn's intense atmospheric pressure. As you descend, the pressure grows crushingly strong, squeezing the life right out of you. It's like diving into the deepest part of the ocean times 1,000. Your fancy suit would start feeling like a tin can under an elephant's foot. Saturn's atmosphere is also mostly hydrogen and helium, so even if you did somehow survive the winds and pressure, you'd have no breathable air. Basically, you'd be gasping for oxygen like a fish at a barbecue. If that's not enough, the temperature changes are brutal. High up, it's hundreds of degrees below freezing, and as you get deeper, it quickly heats up, so you'd go from freezing solid to being cooked alive in moments. Finally, there are Saturn's storms, which are massive and unrelenting. The planet is famous for its hexagonal storm at the North Pole, a swirling six-sided nightmare about twice as wide as Earth. It would be the last swirl you ever see if you got caught in something like that, so while Saturn's stunning rings make it look peaceful, a trip into its atmosphere is more like signing up for a blender ride. Flattened by Uranus's pressure. You've probably heard a lot of Uranus jokes before, but we're not kidding when we say a deep trip into Uranus will make you understand how dangerous this planet is. For starters, Uranus is what's called an ice giant. That's misleading because while it's chilly on the outside, it's got intense layers of gas and pressure as you go deeper in. So even though it's not a solid planet, the atmosphere is no joke regarding pressure. At the outer layers, you might feel like you're just floating through light hydrogen and helium. Descend further, and you're in what can only be described as a crushing pressure cooker. Unlike the Earth, where we have relatively thin air and pressure we can manage, Uranus has layers of gas, getting denser as you go down. The deeper you go, the more the gas presses in on you with intense force. Imagine having tons of air pressing down on every inch of you until you're squished flat like a piece of paper. Eventually, the pressure would become so intense that your body couldn't hold up. Cells, tissues, and bones would all compress and buckle under the intense weight of the atmosphere. Imagine the worst bear hug you could ever experience times 1,000,000. Uranus's pressure is a relentless force that won't stop, and humans are no match for it. You'd likely be crushed before getting close to the planet's mysterious core. If the crushing pressure doesn't get you right away, the cold and toxic atmosphere full of methane and other nasty gases makes it impossible to breathe. Now you understand why Uranus doesn't only sound like the other word for butthole, but is also like the solar system's butthole, full of crushing pressure and toxic stenches. Titan's toxic atmosphere. Let's say you're looking at a brochure of different destinations in our solar system, deciding where to go on your next interstellar vacation. You read that Titan, one of Saturn's moons, has an atmosphere similar to Earth in terms of pressure. That's when you think this could be a good place to chill. But the similarities between Earth and Titan end there. Titan's atmosphere is thick with nitrogen. While Earth also has nitrogen, Titan's nitrogen comes with a hefty dose of methane and hydrogen cyanide, which are as unbreathable as they sound. This means a single breath of air on this moon could mess with your insides and kill you in a matter of seconds. Breathing isn't going to happen on Titan unless you've got a massive oxygen tank. Without it, even the slightest rip in your suit would be like opening the window in a room filled with angry chemistry experiments. You'd be breathing in nitrogen and methane, and that hydrogen cyanide would quickly poison you. It's not the sort of stuff that just makes you cough. Instead, it'd shut down your respiratory system, suffocating you even though the atmosphere feels pressurized. But the big killer here is the cold. Titan's surface temperature is about -290 degrees Fahrenheit. So let's say you step out without the proper thermal gear, you'd freeze solid faster than you could say frostbite. Your bodily fluids would turn to ice crystals, and your skin would lose heat to the icy air in seconds. It'd be like cryogenic preservation, but without the option to come back. Then there's the dangerous surface, because Titan is filled with lakes and rivers, not of water, but liquid methane and ethane. Fall into one, and that liquid would invade your suit instantly, doing its icy work while being toxic. Basically, Titan is exponentially more toxic than your last relationship, because its atmosphere can kill you in all sorts of ways. Pluto's cryogenic chill. Pluto may have lost its status as a real planet in our solar system, but it doesn't really care because it has a heart as cold as ice. This dwarf planet is a bit too chill for its own good, making it one of the deadliest environments in the solar system. The main hazard is the cryogenic temperature, which makes winter on Earth look like a summer day. Pluto's average surface temperature is about -375 degrees Fahrenheit. That's just shy of absolute zero, the temperature at which atoms practically freeze. Forget Frostbite because this environment would flash freeze anything organic in seconds. If you somehow found yourself on Pluto's icy plains without serious insulation, the temperature would suck the heat from your body in an instant, turning you into an ice sculpture ready to decorate the planet's surface. Even if you managed to don a heavy-duty spacesuit, at such low temperatures, gases in your spacesuit would start to condense. Imagine needing to breathe and finding that your life-giving oxygen has turned into tiny droplets, like the world's least refreshing mist setting. And let's not forget Pluto's lack of atmosphere. There's virtually no pressure to hold things in place. Exposure to this vacuum could make bodily fluids like saliva and moisture in your skin boil and freeze simultaneously. This makes a trip to Pluto a one-way ticket to cryogenic death 101. Ganymede's magnetic shock. Ganymede is so large that it has its own magnetic field, which sounds like the world's most often used yo mama joke, but it's real and a rare thing for a moon to have. While that might sound cool, it's actually very dangerous. This moon's magnetic field interacts with Jupiter's much larger magnetic field. Like a charged particle storm, Jupiter's magnetosphere is a huge swirling radiation region. When these particles smash into Ganymede's magnetic field, they create intense bursts of radiation. You don't want to be there when that happens, because it's not the kind of radiation that can turn you into a superhero. Instead, this radiation is powerful enough to fry the electronics in your suit, destroy your oxygen supply, and yes, mess with your very cells. Your DNA is suddenly the main attraction at a particle rave, with high-energy particles busting out moves that leave your cells scrambling to keep up. Prolonged exposure to this would be fatal, and Ganymede doesn't have much in the way of an atmosphere to protect you, so you're exposed to bursts of lethal radiation from Jupiter, especially when the magnetic fields of the two celestial bodies clash. Scientists call this magnetic reconnection, which sounds cool, but is actually the cosmic equivalent of sticking your hand into an electrical storm. This reconnection sends waves of charged particles shooting out, and if you're in the way, there's no suit thick enough to keep you safe from turning into dust. Sliced by lunar regolith dust. Looking at the night sky, you might think the moon is just floating up there, looking pretty. But this large ball of rock is a deadly killer that can turn you into Swiss cheese full of holes through lunar regolith dust. This is no ordinary dust. Forget the soft, fluffy stuff you wipe off your shelves. This is razor-sharp, microscopic debris honed by billions of years of cosmic bombardment. There's no weather or water on the moon to smooth out the edges, so these particles are jagged little nightmares, like ground-up shards of glass. Now imagine those particles sticking to everything because they are electrostatically charged by solar radiation. Think clingy glitter, but it wants to kill you. So if you're an astronaut boldly exploring the lunar surface, there's a good chance your spacesuit will turn into a death trap. The dust infiltrates seals and filters, grinding away at the integrity of your suit. They're essentially microscopic pieces of sandpaper, killing you from the inside. In the worst case, the suit gets damaged enough that it gets depressurized, exposing you to the deadly vacuum of space. It doesn't end there, because breathing in this fine, glassy powder will turn your lungs into a pincushion. Lunar regolith dust can cause lunar silicosis when it gets into your lungs, making it feel like tiny knives shredding your lung tissues. This can cause inflammation, scarring, and suffocation. No space inhaler strong enough can fix this problem. So, as romantic as the moon looks, watch out for that space confetti because lunar regolith dust will slice and dice you faster than a cosmic blender. Skewered by interplanetary micrometeoroids. Space isn't all about starry sights and floating planets, it's more like a deadly pinball machine. The worst part is you're the target. Once you get hit, you're as good as dead. That's basically the gist of getting skewered by interplanetary micrometeoroids. Micrometeoroids are like space's tiny ninjas because they are grains of sand-sized debris zooming around at over 40,000 miles per hour. Even though they're small, their insane speed makes them hit as hard as a bullet. So a speck of cosmic dust can slice through metal and would turn your earthling squishiness into space salsa. Imagine you're chilling in your spacesuit on the moon, Mars, or a spaceship, and a tiny micrometeoroid zips by and nails you. It's like being hit by a super fast bullet. Your suit, gear, and body don't stand much of a chance. It's a cosmic hole punch, like a cannonball going through your body. Micrometeoroids don't travel solo, they're part of swarms, leftovers from asteroid collisions or comet tails, so dodging one is like trying to avoid raindrops in a thunderstorm. If If a micrometeoroid pierces your spacesuit, the depressurization and lack of oxygen will eventually finish you, even if you survive the impact. All this happens seconds before you can even say, "Houston, we have a problem." The good news is spacecraft are designed to handle micrometeoroids, allowing astronauts to feel safe in space. But when you're in the middle of a micrometeoroid shower, you might want to work on your dodgeball skills. Instead of micrometeoroids, we on this channel would like to get bombarded with likes and views, so please subscribe to our channel. Asphyxiated in the vacuum of space. Imagine taking a trek to Mount Everest, the world's highest peak. Up there, the air is thinner, making it harder to breathe. If you didn't train your lungs to handle the thin air, you might die of suffocation before you even get to plant your flag on the peak. Now imagine the same scenario, but you're in space, where the air isn't thin, but basically non-existent. In less than a second, you'll die from asphyxiation in the vacuum of space. Your body needs oxygen to survive. The problem in space is that there isn't a single whiff of air. That's why it's called a vacuum, because it sucks, literally and figuratively. Without air, there won't be any oxygen for your lungs, brains, or tissues. Basically, asphyxiation is your main cause of death. But there's more. It's got a whole lineup of ways to ruin your day. It's unlike suffocating on Earth, where you'd struggle for air. In space, everything happens in an instant. The moment you take your last breath, you're going to turn into freeze-dried toast. Unlike drowning in water, holding your breath isn't even a good idea. The pressure differential forces the air out of your lungs. So if you take a deep breath of air, which doesn't even exist in space, you will rupture your lungs. The whole process takes about 90 seconds to a couple of minutes. If you're lucky, you'll pass out within 15 seconds due to a lack of oxygen to the brain. When your friends realize you've gone full space cadet, you're a bloated, frozen corpse drifting in eternal orbit.